Okay, so we're working on number 11. And Brian, if we screen share with you, do you want to show us your graph?
The thing is, I'm doing it on my tablet, so I think I would have to send the picture to my computer.
Well, you know, if you turn on your video, you can just flip your little tablet around and we'd be able to look at it. You want to try that?
Yeah, I'll try that.
Okay, so I'm going to make you co-host. Your co-host.
Do you just want me to turn on the video from my camera, like the laptop?
Yeah, I think that may be, you know, easiest.
All right.
Okay, I don't know. So I'll stop sharing for a minute, and I don't know if everybody can kind of. Okay. I can see what you did. Can everybody see what Brian did? He graphed the line, and then between 0 and 3, right? The function, that's the space that matters. It's two different like pieces, but it forms a trapezoid, right? Yeah. Brian? And then you can just use the trapezoid formula. Does everybody see that?
Yep.
Okay. And just to kind of belabor the point, because this is important, because you guys are going to see a lot of these in the class, and so let me do a quick share screen for the whiteboard. And okay, so hopefully everybody can see the whiteboard now. And then I'll draw some axes, and this is, hopefully everybody can see, it's like X and Y axes. This is the first quadrant of the Cartesian plane, and that's where most our graphs will be located, like our area of interest. But the line, right, Brian, it goes like this, right?
Yeah.
Yeah, and so then what you did, and I'll just do this like for emphasis, is you said, okay, well,
that's one base.
Yeah, that's one base. And then you have another base at X is equal to 3. Okay. And so this is X equals 0. And this is X equals 3. Those are two different locations in the domain of the function. Oh, and your screen went black. Anyway, you can stop sharing if you want to, Brian.
All right.
Okay. And but now we have the height of this function. And what did you get for the height at X is equal to 0?
I got 3 for the height.
Yeah, which I'm assuming is right, because I can't see the equation right now, but it's just whatever the vertical.
Oh, for Y? What did I get for Y? The Y was 54, because that's the Y intercept.
Okay. Okay, good.
It's because you said X, so I got confused.
Oh, sorry, my bad. You know, okay, yeah. Okay, 54. And then the corresponding value for X is equal to 3, what did you get?
69.
Okay, and so I'm just going to put, well, I don't want to confuse anybody, but you know what I'm going to do? I'm going to make this slope a little bit steeper, only so I can illustrate better the trapezoid. Okay, and then so here you said you have y is equal to 69, right? So then we have our two bases, and hopefully everybody understands what's being graphed and where the values are coming from. If anybody doesn't, now is your chance to speak up. And then you just use the trapezoid formula, right?
Yeah.
So you have the area of trap. Okay. And so you did 54, yeah, plus 69, right? And all of that divided by 2 or times 0.5, whichever you prefer. So that's the average of the bases times the height, which is just the distance between the two bases, right? And so we can see pretty clearly that the distance between the two bases is just 3 minus 0, which is 3, right? 3. And you said that's 184.5.
Yeah.
Okay, sweet. Okay, does anybody have any questions about that? Okay, so I'm gonna go ahead and I'll save that, and then I will stop sharing, and I will share back to Ignithium, and woo. Now, so I think it was Alex who said, "Oh, you can round it to 184." Again, you know, I tell everybody like to get in the habit of doing, you know, what I would call, is commonly called like 2-digit precision, right? So include like 2 decimal places. Now, here where the number is pretty big, yeah, I think you're gonna be absolutely fine, because Ignithium is not going to you know, score it incorrectly. But don't get too comfortable. Again, later on in the course, if you don't adhere to that 2-digit precision rule, then you'll end up missing some points, and that's going to happen, you know, almost certainly on an exam, and you know, if you miss it because you're being imprecise, then you only have yourself to blame. So yeah, try to be careful with the precision, and then you know, won't likely have any trouble. Okay, so let's see. So our team for number 12, so I think Brian O was, it's Brian, Celine, and Keontae. How are you all doing on number 12?
I can share what I got.
Yeah, so what did you get, Brian?
I ended up getting negative 66.5.
So you said negative 66.5.
Yeah.
Okay. And Celine, do you agree with that or disagree? Or Keontae, how are you feeling?
I got 66.5.
Okay, okay.
But it's positive.
Okay, very good. And what about you, Keontae?
I also got positive 66.5.
Okay, okay, good. So I think, so Brian O, probably maybe what tripped you out a little bit is, so it's the higher value in the domain that's listed first, which is x is equal to 3, and then to x is equal to 2. But that's just a distance of 1. I don't know if you understand why it's positive, or do you have a question about that?
Yeah, my bad. I suppose I just didn't think of the graphic. I just went for the integral.
Yeah. So again, this is just a line, and it's the area beneath the line. So again, this is where I said, like, you know, if you're going to use integrals, you got to be careful. I'm not gonna train you or test you specifically except for on, like I said, there are a few things having to do with calculus that we're going to do a little bit later in the course, but it's going to be differentiation. It's not going to be any integration. So if you use another technique, you have to be really comfortable with it. Does anybody not understand how to graph or solve this problem? Because if there are any questions, I'm happy to answer them now. But this is your opportunity.
Yeah, can you just
Question.
go through and solve it?
Can you go through it?
Okay, so Sahib, or is it Alex? Who was
Sahib.
asked?
Both.
Sahib. Okay. Okay, so let me go here and I'll stop sharing and then I'll go back to the whiteboard share. Okay, I'm going to ask you to help me, Sahib. Okay.
I'll try.
Come on, you need more confidence than that. Like, I'm gonna do it. It's gonna get done. Not like, oh well, maybe you can do this. It's no big deal. So first thing we should do is, and again, what I encourage everyone to do, and also remember that the graphs that I'm going to test you guys on later that are going to be, an important component of your grade, especially if you want to get a good grade in the class, because, this class, there's really like two components. One of the components as far as grading is concerned is to make sure you're a competent economist, right? So there's nobody that passes this class that is incompetent. All the incompetent people get screened out. The syllabus is designed to do that. And by screened out, I mean, so you got to take it again. Everybody's welcome to come back again. I'm happy to work with you. But again, this is kind of like, if this was a civil engineering major, this would be our bridge building course. Nobody should become a civil engineer who can't build a bridge, right? Because it's dangerous. And nobody should be an economist without a competent grasp of intermediate microeconomic theory. It is the core of our discipline. The only other thing in our discipline that rivals the significance of intermediate microeconomic theory in terms of the importance to the discipline is econometrics. That's it. So one of the things I was saying before is that, but the other component of the grade, right, is to be like a superstar to the extent you can be, right, in intermediate microeconomic theory and communicating it and using it to others, and that's graphing. So the sooner that you embrace graphing approaches and you practice it, right? Practice makes perfect. So the sooner you do that, the more likely you are to do well in the class. So Sahib, first thing we're going to do is we're going to put down our axes, right? Are you on board?
Yeah.
And I could label them if I wanted to. There's the range of the function and the domain. And so let's graph this function. So what's the vertical intercept? And I know it's a downward sloping function, so I'm just gonna graph it like this. Well, actually, I don't want to do that. Sometimes I wanted to.
Is there a way I can see the question without?
Okay, hold
Because
on.
I can't see the question right now.
Okay, hold on a minute. I'm trying to. It's not cooperating with me, the whiteboard tool. So. Okay, I'll just just do it like this then. Yeah, I'll help you out just a second. I wanted to draw a red downward sloping line like that. Okay, so I'll go. Did somebody put it in chat what the equation was, if they remember or no? Okay.
Yeah, so you're good.
Oh, so it isn't in the chat. Okay, sweet. Thank you, Keontae. Okay, so Sahib.
Mm-hmm.
So the vertical intercept, what's
54.
okay? So it's also, I can put that 54 at x is equal to 0. And we're interested in this area, right? And it's between
3 and 2.
yeah, I'm trying to change the color so it'll show up better. Okay, so that would be 2, and I'm not going to draw this to scale, but just so you can see. So this is 2, and that's 3 in the domain, right? And just to kind of clean things up, let's try. Okay, so what's the value of the function at x is equal to 2?
64.
Okay, does everybody agree with that? Does anybody not agree? I'm not looking at the equation, but you just plug 2 in for x in the equation, and then you get the result, right? So, and I'm just gonna label it over here. So I'm gonna say that this is 64. And what about at 3? What's the value?
69.
Is it 69?
No, it's 79.
It's 7. Is it 79? Does everybody agree with that?
Your
'Cause I
first
thought it was
answer was correct.
I thought it was a downward sloping line.
Yeah, I thought it was minus 5x, not plus 5x on the equation, but I could be wrong.
Oh, okay. Hold on. Wait a minute. Let's take a look. Share screen. Because
No, it
I
was
assume
69, you're right.
so.
is plus 5x. So it should be
Okay.
positive.
So okay. My bad. I thought we were down here, so it's plus 5. So I drew the slope wrong. Okay. So you can see now. So what Keontae put in there was correct. Okay. Okay. Now we'll straighten this out. And it'll look better. Okay. And then I'll move this down to there. And I'll straighten this out here. Move that over there. Okay. There. Okay. So then what should be the height at 3, Siam? Again.
69.
Okay. Good job. So then hopefully you can see, and hopefully you agree, that what we're trying to do is just simply calculate this area here, this trapezoid.
Mm-hmm.
Okay. So can you finish it off?
Definitely not. I don't even know the equation for that.
Okay, well, so we did it before. So the area of a trapezoid, right?
Mhm.
And you should write this down, right? Is the average of the bases. So B1 plus B2, right? Divided by 2. And then you multiply that by the height of the trapezoid, which is just the distance between the two bases. So so that's just this distance here. So what about now? Side. So you may be doing it right now, but I don't know if you.
Yeah, I'm just writing. I'm like trying to catch up for the graph. Sorry, but also for the bases, I'm not sure what number to put in.
Well, okay, just to make sure your eyes are going in the right place.
I mean, I'm looking at the
Right.
left and right side for sure.
Yeah,
I just don't
yeah.
know whether or not it's 2 and 3 or 64 and 69.
Well,
Or-
okay, but okay, I'll tell you now, right?
Mhm.
So 64,
Is the
right,
Y.
it's the length of this line, right?
Mm-hmm.
Right, because X being 2 is just a value in the domain of X. It's a point here on the axis, right? So hopefully this, like when you graph this line, right, this X is equal to 0 and the height right there where what we call the vertical intercept. But now I'll be kind and a little patient, because maybe it's going to take a while for you to be able to see these figures, but right, you and everybody else in this class has been graphing linear equations since you were in 8th grade, right? This is the point 054 is the vertical intercept of this line. And so I know that you know, and if you don't know, and it's time to go do some refresher, like that, what 2 means is it means, a value on this x-axis, right? And 3 means a value on this x-axis. And, when we plot the point, which would be x is equal to 2, y is equal to 64, then, we're measuring in the vertical dimension up to the value of 64. So that's the same as the length of this space. You see what I mean?
Can you say that one more time?
Well, okay, so you've been graphing Cartesian equations since you were in 8th grade, right? I mean, like for a long time, I imagine, right?
Yeah.
So this point, right, is x is equal to 2, y is equal to 64. So that means in the vertical dimension, like what I've drawn here is the base. This is just simply, and I can, emphasize again, I could pick any point in the domain. Suppose I pick the point x is equal to 5, then the value in the y domain, right, is the value of the function there, right? I'm just going all the way up, you see, in the y dimension.
Yeah.
Right. To whatever the value of the function is there. So the length of this base is 64. Do you see what I mean?
Yeah, I see it now.
Yeah. And the length of this one is
Yeah, no, it's kind of obvious now that you say it.
Yeah, well, I mean, I have to say, I mean, you would not be alone. Well, and I'll tell you how you wouldn't be alone, because so even though you all have been doing this type of graphing since you were, 13, 14 years old. Because econ is an applied math discipline, we use all that stuff just like, it's second nature. And since we do it a lot, we get good at it as economists. But there are a lot of people that, especially people in principles of economics, is you would think that they had never had a day of math in their whole life. And what I mean by that is I can draw supply and demand diagrams and things like that in principles of economics. Somebody's, a history major or a comm major, and they're taking it, and they just don't recognize. And you know what is the thing that confuses people the most in principles is you see, Y is an arbitrary label, right, for the vertical dimension of the graph. And most of the times in economics, we label this that dimension as price, right? And we label the horizontal dimension as Q. And as soon as I switch from X's and Y's to P's and Q's, oh my gosh, you would think that, I just like completely broke a bunch of people's minds. They don't understand that X isn't literal. In fact, a little bit of a mathematical history lesson is that the X label that we use. So we're talking back in 1800s. When Rene Descartes and other people first started doing this sort of graphing, they called what we call now the domain of the function, the horizontal dimension, they called it the abscissa. So this is, probably, and I'll write it here, domain is equal to horizontal dimension is equal. And so the double equal sign means it's a definition, just if you haven't. So they use this word abscissa. And do you know what they called the vertical dimension?
Range.
No. Okay, so we say it's the range, or sometimes people say, it gives you the value of the function. Those are all fine, which is, the vertical dimension. But back then they called it the ordinate. So yeah, but whether we want to call the abscissa X or we want to call the abscissa Q, and we want to call the ordinate Y, or we want to call it P, we're just graphing, relationships between the objects that we're interested in, right? So in our case in economics, we're interested in the relationship between price and quantity a lot of the time. So as applied mathematicians, we'll label the abscissa and the ordinate in a way that's convenient for us. But as soon as I do that in principles of economics, get rid of the X's and Y's and use P's and Q's, you would think I was defining like a new area of math or something like that. I mean, I have to remind people of all this stuff. That is kind of obvious, but maybe they haven't applied it in a while, or they kind of forgot. So yeah, you are not alone.
I think it's been a while, honestly.
Yeah, but hopefully it starts snapping, because I know that, you're an econ major, right?
Yeah.
Yeah. And I know you can do this stuff because you've done it before, and probably, I don't know, have you had calc?
Yeah.
Yeah, so I mean, come on. Like, I know that this is well within your capabilities. So, but it is kind of a little bit subtle. I even have students, and you would maybe be a little bit surprised, but I'll just say this because maybe it will make you feel even better. I have students that are double majors in math and econ. So I know they're good math students. But when we do stuff like this, a lot of them struggle. So it's not just math, it's being able to utilize the math in sort of a novel, meaning like an original or a different way to examine the things that we're interested in. Anyway, okay, I've given my spiel. But this is a lot of what we're going to do in this class. So so you have an answer for us?
66.5.
66.5, right. And those were also what we got from the answer that we got from Keontae. And does anybody else have a question about this before I leave the screen? No. Okay, so stop sharing. And we go back here. So
Professor?
Yeah. And
will you
hold on,
be
I
able
just want to do one thing first, and that is, so it was Keontae and Sahib, and who was our other O'Brien? Oh, I'm clapping for you all. And so is the rest of the class. Good job. Okay, so there was a question.
Yeah, would you be able to explain number 19 briefly?
Okay, yeah, perhaps, because so let's who is 13?
I'm 13. Yeah.
Me.
Okay, and so this is the same except for the it's a downward sloping line instead, right? And what did you all get?
I got a 41.5.
And
Yeah.
yeah, everybody agrees.
Yeah,
Whoop,
yeah, me too.
whoop, whoop, whoop. That's good job. Okay, does anybody have any questions about that? Same thing that we just did, but there's okay. So about 14.
I got 7.29.
And our other 14 people?
7.29, yeah.
I got the same, but I left it in 51/7.
Okay, which if you put it in your calculator.
It's the same thing, yeah.
Okay, good job, good job.
Professor.
Yeah.
So for number 14, we have to do like to find the x. We have to do for like the y intercept for that.
Yeah. So this one is worth spending just a second on, and so I'll do that, and then I'll try to get down to number 19 to talk about it really quickly. So okay. So you folks that are in charge of number 14, you should have these equations written down so you can help me because I'm going to move over to the whiteboard really quickly. Okay. All right. So okay. So in this case, we have a downward sloping line, right? And we have an upward sloping line. And what we're trying to figure out is what's the value of the point at which they intersect, right? And that's the question. Does everybody agree?
Yes.
Okay. So, and just so you know, it's really common for us to label this as X star and this value over here as Y star, right?
I went in for a little bit, but I left. Why?
Okay, so somebody has They're not muted. Okay, we're good. Okay, so does everybody understand what I'm talking about here? Does anybody have any questions? Just to be super clear, you know, this is our value in the X dimension, and this is our value in the Y dimension, X star and Y star. Okay. And I'm gonna open. And this. I'm just gonna get rid of these arrows over here. Okay. Just because I don't want to clutter our graph. Okay, I'll probably over there. Okay, so for our equations, what are our equations? The downward sloping equation is what, you all that were helping me? Y is equal to blah, 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 blah.
54 minus 5x.
54 minus 5x. Okay, so I'm just going to label it down there. And for the upward sloping one, it's y is equal to, what's it, 3 plus 2x or something?
Yeah.
Yes, 3 plus 2x. And then hopefully you all can see that these are it's 54
you forgot the 5.
5x.
5x.
Yeah. Okay, thank you. Okay. So this is a system of simultaneous equations. So there's two equations at the same time. You know, obviously X tells us the value at X at which both of these functions have the same value Y. It's the point at which they cross, right? Because they both occupy that same point. And so whenever you're going to solve a system of simultaneous equations like this, you use the technique called substitution and elimination. So basically, you can do it any way that you really want to, but you know the most straightforward way to do it, based on the way these things are set up, is you take this Y value and you substitute it in for Y there, and then you end up with one equation in X. So I'll just write down here. So then I would get 3 plus, and maybe I can do even better here. Let's try to do it in purple. 3 plus 2x is equal to 54 minus 5x. Okay. And now I have one equation in one unknown, not two equations in two unknowns. The two unknowns would be X and Y. Now I just have one equation in X alone, and I can solve for X. So in this case, it's pretty obvious, I think. So an intermediate step would be 7x is equal to 51, right? And then I would get x is equal to 51 divided by 7. And this would be the x star, the place in the domain at which the two lines intersect. And does everybody agree with me, my helpers for this particular question?
Yes.
Okay. And so then our final value, did we say it was 7.29? Was that?
Yes.
Okay, 7.29 in decimal form. Okay, so Hung, I think you were the one that asked the question. Does that make sense to you?
Yes.
Okay. So, and then if we wanted to get the value in the Y domain, we would just plug this into either one of these equations. So again, the most common thing that folks do, if you know you're interested in doing it the way that other people do it, is they would plug it back into the first equation, right? And then you could evaluate. Does anybody want to tell me what y star is then? Okay, I'm waiting.
Y star would be 17.58.
Okay, and okay, 17.58. Does everybody agree? Okay. All right. And okay.
Yeah.
Okay. And then we'll go back to Ignithium. Sure. Okay. Okay.
Gotta check.
So, all right. So somebody asked about number 19 and okay. So X1 is a point of intersection, so that should be clear. Oh, okay. So I won't go all the way through this one, but I can talk about it just for a second, right? So who asked the question about number 19?
Me, Brian F.
Okay, so Brian, so hopefully you can see, right? So they're saying X1 is the point of intersection and X2 is X1 plus 5, right? And you have these two equations, right? So if I go stop share here and I go share back to the whiteboard, so we already know what, okay, hold on. Okay. So we already know what X1 is. That would be the X star, right? And I would add 5 to it, right? And then I'd get a value. I'll just kind of exaggerate it a little bit. It depends on, again, the scale. So this would be X star plus 5. Oh, 5. And then, so ultimately what I'd be looking at, does this make sense, Brian Madris, right?
Yeah.
Yeah. So then what I would be looking at is, I think it asks for the distance between these two functions. Like over here. Does that make sense?
I think I asked for the difference of the areas under the curve.
Yeah, right. Okay. So there would be the area under the red one, right? That would form a trapezoid here. Can you see what I mean?
Yeah.
Right. And then the area under the blue one, you would subtract off of that. And what would be left over, right? Well, what would be left over would be this area, right?
Yeah.
Did that help?
Yeah.
Okay.
Can I see the original question real quick?
Yeah, hold on, wait a minute. I don't know about real quick, but I'll show it to you. Share screen. Okay. It's this one, number 19. You good?
But I think the red line goes to the negative side.
The negative side.
Yeah, so I'll go under the y equals 0. Does that matter? Which would be y equals 51 minus 5x.
Okay. Well, right. So you'll have to play with it a little bit, right? Okay. So you are right that in general, right, we would in economics, if this wasn't like here, there's no context, right? This is just like pure math, right? So like naturally, we're interested in like positive prices. So if there was a part of the graph that went into the negative part of the range, we wouldn't have negative prices, so we wouldn't use that, right? That wouldn't be part of the area we were interested in. And so you have to play with it a little bit and do it both ways and try to see what they're looking for exactly here. And we can talk about it again next Tuesday for a little bit, but I'm going to stop sharing here because we moved on into our regular class session, and I'm going to stop recording.